All right, so let's continue on with example 7. Again, directions ask us to factor. And when we look here, we see that there is a common factor that all three of the terms share. Not only is there a numeric factor that all three terms share, but there's also a variable factor that they share. So the numeric factor that 24, 100, and 100 have in common is 4. And then the variable factor that x cubed, x squared, and x have in common is x. So when we factor that out from all three expressions, we get 6x squared plus 25x plus 25. And we want to take that quadratic function and factor it. Okay, so we're going to do exactly like we did in the previous examples. So the number that's going to go on top is 25 times 6. It's the constant times the leading coefficient. And 25 times 6 is 150. The number that goes on bottom is the coefficient of x, which is 25. So we're looking for two numbers that multiply to give 150 and add to give 25. And those two numbers are going to be 15 and 10. Don't worry if you can't figure it out that fast. The more you practice with it, the better you're going to get. Okay, so we're going to leave that factor alone out front, and then we're going to take the middle term and break it up into two terms using those coefficients. So this is going to become 6x squared plus 15x plus 10x plus 25, and then we're going to factor that by grouping. So again, I'm going to separate 4x from everything else. Okay, so when I look at 6x squared and 15x, the factor that both of those terms share is 3x. When I factor that out, that leaves me with 2x plus 5. And then when I look at positive 10x and positive 25, the factor that they both share is positive 5. When I factor that out, that leaves me with 2x plus 5. Okay, so 2x plus 5 is the common factor. So when I factor out 2x plus 5, that leaves me with 3x plus 5. So that is our next factor. Okay, so that expression is going to factor to 4x times 2x plus 5 times 3x plus 5. Okay, let's look at number 8. So with number 8, we have x squared minus 81. And we can use the same technique for factoring this as well. There's no common factor for me to factor out. So the number that goes on top is going to be the product of the constant term, which is negative 81, times the leading coefficient, which is 1. So that's negative 81. And when we look here, there is no middle term. So if you want, like, you can think about rewriting this as like x squared plus 0x minus 81. So the coefficient of the middle term is going to be 0. So we're looking for two numbers that multiply to give negative 81 and add to give 0. And they are negative 9 and 9 respectively. All right, so I'm going to take that middle term 0x and I'm going to split it into two terms. The first term being negative 9x, the second term being positive 9x. And then we're going to factor this resulting polynomial here by grouping. So when I look at the first two terms, the greatest common factor of those first two terms is going to be x. When we factor that out, that leaves us with x minus 9. And then when I look at the last two terms, the greatest common factor of the last two terms is positive 9. When I factor that out, that also leaves me with x minus 9. So x minus 9 is the common factor. And then when we factor that out, that leaves us with x plus 9. Okay, and that approach for that problem is completely fine. But there's a faster way to do problems of this type. Okay, when we look at x squared minus 81, that is the difference of two squares. It's like saying x squared minus 81, which is 9 squared. When you have the difference of two squares, okay, a squared minus b squared, a faster way to factor that is that's going to factor to a minus b times a plus b. So the difference of two squares, a squared minus b squared, factors to a minus b times a plus b. So if x squared minus 81 is x squared minus 9 squared, that factors to x minus 9 times x plus 9, which gives us a faster way to factor expressions of that type. Okay, last two examples we're going to look at. The directions ask us to solve the equation. Okay, so this is different. Here we have an equation that we have to solve. So the first equation I have to solve for the variable y. And the second equation I'm going to have to solve for the variable x. We're still going to have to factor in both equations. But rather than stopping whenever we factor, we actually have to solve the equation for each of the variables. Okay, so when we look at number 1, again, the first thing we want to do is see if there's something that I can factor out of the two terms, which there is. There's a numeric factor of 5 that we can factor out. And there's also a variable factor of y that we can factor out as well. So when we factor out 5 times y, that is going to leave us with y squared minus 25. Now, hopefully, this looks familiar. Y squared minus 25, because I showed you in the previous example a faster way to factor something of that type. Okay, again, y squared minus 25 is y squared minus 5 squared. So that is going to factor to y minus 5 times y plus 5, which we are multiplying by 5y. And that product has to be equal to 0. Okay, so what does that mean if a product is equal to 0? Well, for a product to be equal to 0, that means that in this particular case, either the first factor, 5y, is equal to 0. The second factor, y minus 5, is equal to 0. Or the third factor, y plus 5, is equal to 0. And then all we have to do is solve each equation for y. So if I take the first equation, divide both sides by 5, we get y is equal to 0. If I take the second equation and add 5 to both sides, we get y is equal to 5. And then if I take the third equation and subtract y on both sides, we get y is equal to negative 5. Now, you can use the same technique that we've used in the past to factor this here as well. It's just easier if you recognize that as the difference of two squares. A squared minus b squared factors to a minus b times a plus b. That's something that you want to know. It's something that gets used a lot. It's something that's going to come in handy for you to factor the difference of two squares in a faster, more efficient way. Okay, I want to see what you guys do with 2, so go ahead and give number 2 a try and pause the video, and then we'll work it through together at the end. Okay, so when we look at number 2, this is a little bit different than what we've done to start with, because this polynomial here has 4 terms. And there's nothing that we can factor out of this polynomial to start with. So when our polynomial has 4 terms, the only technique that we have right now for factoring that is to factor by grouping. Okay, so what is the greatest common factor of the first 2 terms? Well, that's x squared. And when we factor that out, that leaves us with x minus 3. And then I want to factor something out of the last two terms where it leaves me with x minus 3 in parentheses. So if I factor -1 out of the last two terms, that also leaves me with x minus 3 in parentheses. Okay, so x minus 3 is the factor that both quantities share. When we factor that out, that leaves us with x squared minus 1. So that is our second factor. But we're not done yet, because when we look at x squared minus 1, that is also the difference of two squares. So I can factor that expression further. X squared minus 1 is like saying x squared minus 1 squared. So that is going to factor to x minus 1 times x plus 1. And if that product is equal to 0, that means that one of the factors has to be equal to 0. So x minus 3 has to be equal to 0, or x minus 1 has to be equal to 0, or x plus 1 has to be equal to 0. And when we solve each of those equations for x, first equation gives us a solution of x is equal to 3, second one gives us a solution of x is equal to 1, and the third one gives us a solution of x is equal to -1. All right, so those are your three solutions for that particular equation. Okay, so that wraps up this lesson, and we'll continue on in class soon. So we'll see you guys on Monday. Take care.